In this video, we will talk about the derivation of radius ratio rule and deviation from this rule. Now look at this. This represents a tetrahedral hole, and these are four anions which are making this hole. So if these are anions, the cation will take place in this tetrahedral hole. So we can assume the radius of hole is equals to the radius of cation. So now we have to calculate the radius ratio between the radius of this cation and the radius of this anion. So look, OB is equals to OC, which is this OB equals to OC. So OB and OC, these are which equals to R, where R is the radius of the anion and RH is the radius of the hole. So OB and OC are equal, which is R plus RH. Now BC is equals to 2R. All these sides BC, CD, AD all are 2R. These two anions are also in touch with each other, but for the simplicity I have shown like this. Now OM is perpendicular to BC. OM is perpendicular to BC. So angle OMB, this angle OMB is 90 degree. So this is 90 degree. And OM bisects the angle BOC. This angle is being bisected by OM. So angle BOC, this is 109.5 degree. Because this is a tetrahedral shape, so all angles are 109.5 degree. So half of this BOM will be just half of this. And now from the calculation of this triangle, we will get that BM by BO, this is our right angle. BM by BO is equals to sine of 54.75 degree. And again BM is equals to R, which is the radius of the anion, and BO equals to the R plus RH. So from this calculation we will get 1 by sine 54.75 is equals to 1.225, and with a brief calculation we will get RH is equals to 0.225 R. That means the radius of this hole is 0.225 times of the radius of this anion. So, and we know that the hole is being occupied by the cation. So this gives the radius ratio RH by R is equals to 0.225. Now look at this. This is actually an octahedral hole. And these are four anions. One is in the up and other one is in below of this hole. So we have taken the radius of this hole is RH and the radius of anions are R. So AB is basically formed with 2R and plus 2RH. So this one is R, this one is 2RH and this one is R. So AB is equals to 2R plus RH. And now AC and BC, these are 2R, radius of two anions. So from the Pythagoras theorem, we will get AB square is equals to AC square plus BC square. And we just put the values. So from calculation, we will get RH is equals to 0.414 R. So the radius of this octahedral hole is 0.414 times than the radius of this anion. Now see. This one is just a simple cubic structure. So 8 corners are being occupied by 8 anions, and this is the hole formed by these 8 anions. So we have to consider the body diagonal, and AB, this is the edge length, which is equals to 2r. So AB is equals to 2r, where r is the radius of anions, and AC, the body diagonals, which is equals to root 3a, is equals to 2r plus rh. Look this, the body diagonal AC. After this one is r, and this is the diameter of the hole, which is equals to 2rh, because the radius is rh, so the diameter will be 2rh, and this one is also r. So AC is equals to 2r plus 2rh, and with a brief calculation we will get rh is equals to 0.732 r. You can see the calculation. So the radius of this hole is 0.732 times than the radius of this anion. So the radius ratio RH by R is equals to 0.732. So actually from this is the theoretical approach. From this we will get that if the radius ratio is greater than 0.732, the coordination will be 8. And if the radius ratio is between 0.414 and 0.732, then the coordination will be 6. And if the radius ratio is in between 0.225 and 0.414, then the coordination number is 4. But there is some deviation from this theoretical approach. If we consider the lattice energy of the CaCl, NaCl, and ZnS type compound, then we will see this diagram. Now from going 0.225, and if we increase the radius ratio at the value of 0.32, this NaCl type compound have the higher lattice energy. That's why if we increase the radius ratio, increasing it from 0.32, we will get the NaCl type structure. And again in this case here, from the theory we will get that 0.414 to 0.732, the structure will be NaCl type. But actually if we increase the radius ratio from 0.71, then this NaCl type of compound has lower lattice energy. That's why after or sorry that's why if we increase the radius ratio from 0.71, the compound will try to adopt the CaCl type of structure, which has higher lattice energy than the NaCl type of structure in this zone. So see this graph very carefully and do all the calculations yourself. Thank you for watching.